Hey guys, hello everyone and welcome to the channel. So today in this particular video we are going to talk about oxoacids of phosphorus and sulfur, and I'm going to give you some trick to remember the name and to remember the structure of the compounds, right? This is one of the topic from where direct questions have been asked already in CSIR NET exam, and it is very much expected that in the upcoming exams also the questions will be asked from this topic. So this makes this topic from the main group element a very important one. So before starting anything about the video, let me tell you about the classes of mine which are running on Unacademy Plus, and there are two new classes that are going to start. One is going to be for the GATE 2021 batch and the other one is going to be for CSIR NET upcoming batch. So if you are interested in that, you can mail me in the email provided in the description of this video. Now having said that, let's continue with our video. Alright, so the first thing which we are going to talk about is oxoacids of phosphorus. Now, in the oxoacids, there are few basic things which you should need to know, okay? So, few basic things are there that in the oxoacids, the necessary thing is that with phosphorus, you will have double bond O, okay? This is a very important thing which will be always there in the oxoacid, and a single bond OH. So, this fragment or this unit you will get in all the oxoacids. This is the definition of oxoacids. So for phosphorus, you are going to get P double bond O and single bond OH, that you are going to get everywhere. Okay, so this is first thing. The second thing is with the nomenclature. Okay, so there are two nomenclature you are going to get. You are going to get ic at the end and you are going to get us at the end. Okay, so ic acid and us acid. These are the two names which we will come across generally. So ic acid generally correspond to higher oxidation state, okay, and us acid correspond to lower oxidation state. Now you know that phosphorus basically can have the highest oxidation state of phosphorus can be +5, it also shows +4, it also shows +3, and it also shows +1. So these are the lower oxidation states and these are your higher oxidation states. Now if you understand this much, you are pretty much good to go, and you can find out all the structures of the phosphoric, like all the structures of oxoacids of phosphorus. Okay, so let's try to do it. Alright, so in the oxoacids of phosphorus, you have two basic series. One is called as your phosphorus acid series and the other one is phosphoric acid series. Now you know what your phosphorus acid is, right? You know your phosphorus acid. The structure for this, or the molecular formula for this, is H3PO3, right? And phosphoric acid, you know, your phosphoric acid is basically H3PO4. So with the help of these two, we are going to derive all the oxoacids of phosphorus, and the similar thing we are going to apply on the sulfur also. So first let's continue, or first let's finish this phosphorus and then we'll do for the sulfur one, right? Alright, so first let's talk about this phosphorus acid series. In this series, the first oxoacid will be a phosphorus acid itself. Okay, phosphorus acid itself. Now the formula for this is H3PO3. You have to memorize this formula. Now what will be the structure of this? Okay, how to find out the structure of this? I already told you that this P double bond O and OH is a very necessary condition for all the oxoacids of phosphorus. So it is going to stay like that. Now out of these 3 hydrogen, you have utilized one of the hydrogen. Out of these 3 oxygen, you have utilized 2 oxygens. So you are left out with one more oxygen. So just you can use that oxygen like this, and one hydrogen you can put like this, and you are also left out with one more hydrogen. So here it is. So this is how it will go. You can see that phosphorus can make at most of 5 bonds. So this is how you have to make it. Now to find out oxidation state of this is not going to get find out from this like a structure. You have to draw the tautomer structure of this. So this molecule shows tautomerization. How does it show? See, oxygen being more electronegative, it attracts the lone pair of, it attracts the pi electrons towards itself, creating a negative charge on this oxygen and a positive charge on this phosphorus. So what we are going to expect is this, and this OH and this OH and this H is already here. Now in the next step, here we will get positive charge. Now in the next step, what will happen, that this bond pair is going to get collected towards phosphorus, and this hydrogen is going to get bind to this, forming the final structure of this, or forming a tautomer structure of this like this. It is going to be like POH, OH and OH. So this particular phosphorus acid can also be shown like this. These two are resonance structures of each other. What is the oxidation state of this? So if you see the oxidation state, you will find that it is +3, okay, because I already told you that US or OUS series follows +3 oxidation state. So here you have +3 oxidation state in this, okay. Each OH group is going to contribute -1, so you can calculate it's +3. Don't calculate with this structure, otherwise you will get +5, okay. So don't get confused with it. Due to the resonance structure, this particular one gives you +3, and that is the oxidation state of it. Alright, now once you are done with one of the phosphorus acid, let's go for the other derivative of this, okay. So now with the phosphorus acid, we are going to derive the other oxoacids of this. So let's do it. Now this is your phosphorus acid. Now I can derive one more structure from this. What I can do, if I just remove one oxygen, okay, if I just remove one oxygen atom over here, I can remove either oxygen from this OH or from this OH, I'll get the other oxoacid. So in that I'll get P double bond O and OH. See, this is very necessary. This thing should be there to make the compound oxoacid. I have removed one oxygen from here, so I just got H and H. Now since you have reduced it, because you have taken out oxygen, so it's a reduction which you have done. So whenever you reduce something or whenever you do reduction, that is called as hypo, okay. So we represent it as hypo. So this will be like hypophosphoric phosphorus acid, okay, phosphorus acid. The oxidation state in this case will be +1. Remember, because you have changed or you have reduced it from +3. So that's why the oxidation state becomes +1. Now this is one of the oxoacid which I have derived from your phosphorus acid. The other one which I can derive is by taking 2 molecules of this, okay. If I take 2 molecules of this, so what I am going to do is I am just going to take 2 of the molecules of this. So let's say I have I am just going to do it here, okay. So I have P double bond O and I have H, OH and OH, and if I take the other molecule as well, OH, OH and H. Now what I can do, I can just like remove water molecule from here, okay. I can just remove water molecule. So removal of water molecule gives you pyro acids, okay. So that gives you pyro acids. So the structure which you are going to get will be this P double bond O, H, OH, okay. Then since you have removed water, so one H and OH will be removed. One oxygen is left out here, right? So that oxygen will be here, and the rest of the molecule you just have to draw it like that only, okay. So this oxoacid is called as your pyro phosphorus acid. The oxidation state is still +3, okay, because it is phosphorus acid. Now with the help of phosphorus acid, we have formed 2 of them, okay, hypophosphorus acid and pyrophosphorus acid. Same we can do with the help of phosphoric acid. So let's try to do the phosphoric acid series. Alright, so let's try and do for the phosphoric acid series. The first oxoacid for this will be your orthophosphoric, okay, phosphoric acid, or also called as just phosphoric acid, okay, phosphoric acid. So both the names are there, either you can call it orthophosphoric acid or just phosphoric acid. The formula for this is H3PO4. I already told you. The structure of this will be, you have to draw it in the same way. P double bond O and OH is compulsory for all the oxoacids, and then you, since you are left out with 2 oxygens you have used, 2 more oxygens you are left out with, so just bring 2 oxygens like that, and since you have used 1 hydrogen, the other 2 hydrogens are left out, so they will be like this. So this is your orthophosphoric acid or your phosphoric acid, okay. The oxidation state which you will get for this molecule is +5. Now with this we are going to derive the other derivatives of it, okay. So the first one which you can do is your metaphosphoric acid, okay. So with the phosphoric acid, what I will do now, so I am just going to remove water molecule from here. So how I am going to remove this water molecule? By taking this this particular species. Okay, so I can just remove this part. So what I'll get is P double bond O, OH, and with this oxygen now a coordinate bond will be formed, because phosphorus is going to donate all both of these lone pair electron towards the oxygen. So this particular one is called as your meta phosphoric acid. Okay, phosphoric acid. The oxidation state in this case, since it is ic acid, so it will be 5 plus 5. Remember, for ic acid the oxidation state should be higher, that is plus 5 or plus 4. For us it will be plus 3 or plus 1. When it will come hypo, right, whenever hypo will come, you have to just remember like this, that for ic acid you will get plus 5, for us acid you will get plus 3, but when the hypo comes, your plus 5 becomes plus 4 and your plus 3 becomes plus 1. That's all. Okay, that's what you have to memorize. Okay, we can derive the other acids as well. So from this we have derived one of them, that is metaphosphoric acid. The other one which I can derive is your let's say I add O2 molecule in this. Okay, I'm just going to add O2 molecule. So that is going to give me P double bond O, OH was already there. This OH was already there. In this OH I am just going to add a oxygen atom. So if I add oxygen atom, this is what I will get. Okay, so in this OH I have added one oxygen atom. Instead of writing it as molecule, I should rather correct it up and it's an atom. Okay, so oxygen atom is being added. So if you add this oxygen atom, this is what you will get. The name of this is called peroxo mono phosphoric acid. Phosphoric acid. The oxidation state again is going to be plus 5 only. Okay, so its oxidation state will remain plus 5 only. So we have derived, see, two of them we have derived. We can derive more of them now. See, the next one which we can do is by taking two molecules of that. So that for that I'll use the next slide. So this was my phosphoric acid. Now I'm going to derive some more oxoacids from it. Okay, so if I take 2 moles of it, okay, if I take 2 moles of it and if I react it just like we did in the previous one to form pyro one, okay, to remove one water molecule. So for that what I am going to get, again the same thing, P double bond O, OH, 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 and if I react with 1 mole of that, so OH, OH and OH. So in this case what will happen, that one water molecule will be removed and one oxygen will be left out at the center. So what I am going to get is basically P double bond O, OH, OH, O, P double bond O, OH and OH. What will be this called? When you remove one water molecule from the oxoacid, from 2 moles of oxoacid, it is called as pyro, right? So that's what will be the name, pyro phosphoric acid. Okay, so this is pyrophosphoric acid. The next thing which you can do is you can remove this oxygen at the center. Okay, so if you remove this oxygen which is present in the center and you just directly form this phosphorus bond, so basically what you are doing is you are reducing this. Okay, so if you are removing a oxygen molecule from this pyrophosphoric acid, okay, if you remove one oxygen from here, so basically what you are doing is you are reducing it. So in that case its name will be hypo. Okay, so what you are going to get is P double bond O, P double bond O, this oxygen just got away, you got OH, OH, OH and OH. Okay, this is what you have got. The name of this is your hypophosphoric acid. Phosphoric acid. Now the oxidation state in this case, in this particular case, will remain plus 5 only. How to find out oxidation state? This is phosphorus, this oxygen will make -2, this is going to make -1, -1 and -1. So it all together make plus 5. In this case the oxidation state becomes plus 4. Okay, because phosphorus bond does not contributes to the oxidation state. So -2 and -1. So this overall the oxidation state is going to be plus 4. The other reason for this being plus 4 is because its name contains hypo. Hypo means it is reduced form, the oxidation state will be 1 less than the general like the one which is being told by here. So ic is telling that it should be in highest oxidation state, that is +5, but hypo is telling that it should be 1 less than that. Okay, so instead of 5 you are getting 4. In the same way, for phosphorus acid the oxidation state is +3, but hypophosphorus acid will have oxidation state of +1, because hypo is telling that that is the reduced form of that. So these are all like 5 or 6 oxoacids of your like which can be derived from your phosphoric acid series. So we have got 5 from the phosphoric acid series and we have got 3 from the phosphorus acid series. 8 oxoacids are there. I hope you understood how to do that. Now let's take the oxoacids of sulfur and see how to derive them. Alright, let's talk about oxoacids of sulfur. The same concept you have to apply here as well. The first rule is that for being an oxoacid, the eligibility criteria is that sulfur should have double bond O and OH, just like for the phosphorus. Same thing is here also. And the second criteria is that if you have ic acid, okay, in that case you have higher oxidation state. Higher oxidation states are +6 or +5. Okay, these are higher oxidation state. And if it is us acid, in that case it will have lower oxidation state. Lower oxidation states are either +4 or +3. Okay, or +3. Now you know when this +5 and +3 will come in the case of hypo, right? So the same thing is there. Hypo means like when it is hypo, in that case you have to deal with these. Okay, if you have hypo, so in that case you have to deal with this. Fine. So now here in the oxoacids of sulfur you will have 4 series. Okay, just like we did in the two series were there in the oxoacids of phosphorus. Here we have 4 series. The first series is of sulfurous acid series. Okay, the second series is sulfuric acid series. The third series is thiosulfuric acid series, and the fourth series is pyrosulfuric acid series. Okay, and we are going to find out 11 different oxoacids of sulfur here. Okay, so let's go for each and every series one by one and let's see how to find out the structures of them. The first series which we will talk about is sulfurous acid series. You know the oxidation state will be either +4 or +3. Now you have the first of it. The first one will be the sulfurous acid itself. Okay, sulfurous acid itself. The formula for sulfurous acid you have to memorize, and that is H2SO3. Alright. Now let's try to draw the structure. The criteria which we have for the structure is S double bond OH, that we will be having. Now out of 3 oxygen we have used 2 of them. Out of 2 hydrogen we have used 1 of them. We are left out with 1 oxygen and 1 hydrogen. So they will be just written like this. Okay, so this is the structure of it. The oxidation state which comes out over here, -2 for this and -1 and -1 for this. So overall sulfur will have +4 oxidation state in this case. Alright, so this is the first one. Okay, second one, what I am going to do is I am going to find out for thiosulfurous acid. Okay, sulfurous acid. So whenever this word thio comes, okay, this word thio comes, what does it means? It means that remove oxygen and insert sulfur. Okay, so remove oxygen and insert sulfur. Which oxygen you have to remove? To be very specific, if you will remove double bonded oxygen, it will be much better. If you don't remove double bonded oxygen, you have to do the resonance structure and then get back to this. But the criteria is you should remove the double bonded oxygen. So let's try to check it out. So here earlier we were having this as the sulfurous acid. If I remove this double bonded oxygen, so what I am going to get, and I have to insert sulfur here. So I will be getting S double bond S, OH and OH. This is my thiosulfurous acid. Let's say we are not doing in this way. Okay, we are trying to do it in the other way. That means I just want to insert this oxygen. Okay, I want to remove this oxygen and insert sulfur here. So can I do that? Yes, I can, but in that case you have to resonate the structure. How the resonance will happen, just understand this. Okay, so this lone pair of sulfur, because oxygen being more electronegative, it will try to attract this electron cloud towards itself. The next structure which we will get is going to have S single bond O minus, and here it will be double bond SH. On this sulfur will have positive charge, and here I'll be having OH. Now obviously this oxygen, this particular hydrogen is going to leave this bond and it's going to attack on this oxygen, right? In that case this sulfur will also get neutralized, and oxygen will also like neutralize its charge. So the next structure which we will get will be SOH double bond sulfur and OH. See, this and this are same. So you can get back to this just by doing the resonance thing a little bit, okay? So this is your thiosulfurous acid. The next one is your, the third one is your pyrosulfurous acid. Pyrosulfurous acid. What you have to do? Remember, in pyro what we have to do? We have to remove water molecule, right? That's what we were doing in the phosphorus compounds as well. So we have to take 2 mole of it. So S double bond O, OH, OH, and plus we are going to take S double bond O, OH, and OH, and we can just remove this thing, and then we'll form this SOS double bond O, double bond O, and OH, OH. It seems pretty simple, right? But this is not correct, okay? This is not correct. You cannot do like this. Pyrosulfurous acid will not be made like this. Just like for phosphoric acid, it was simple to make pyrophosphoric acid just by removing the water molecule, but here that simplicity is not allowed. So now I am going to show you that how actually that pyrosulfurous acid is going to get formed. So basically in the first step, the lone pair of this sulfur is going to attack on this sulfur, making this bond shift to this side, and the thing which you will get is sulfur sulfur single bond. This is going to have double bond OH and OH. Here in this sulfur I will have O negative charge, I will have OH, and I will have OH. In the next step, what will happen, that this electron is going to come here, and this bond is going to move like this. So removal of an OH minus species is going to happen. So what is going to get formed? The species which I'll get is sulfur double bond O, I'll have OH, OH, sulfur single bonded here, double bond O, and I will have OH. Okay, so that's what I got, but it's not a stabilized structure. So in the next step, what is going to happen? This lone pair of oxygen is going to shift like this, and this OH which has been eliminated is going to attack basically, okay? So this OH minus is going to take this hydrogen along with itself to make water molecule. So water removal will happen. That's what the pyrolysis or the pyro name suggests. So water removal will happen, but not in a simpler way. Through this mechanism it will happen. So what will happen in the next step? What is going to get formed? S double bond O, then you have OH, then you have S, and here you got double bond O, and here it was double bond O and OH, right? So this basically is your pyrosulfurous acid. Okay, so this is pyrosulfurous acid. What is the oxidation state? So both the sulfur are in 2 different oxidation states. This sulfur over here is in +5 oxidation state, whereas this one is in +3 oxidation state. So that's how pyrosulfurous acid will be formed. Alright. The next one is your hyposulfurous acid, and that you can find out from your pyrosulfurous acid only. So in that you just have to remove one oxygen. So in the same, this pyrosulfurous acid, once it is formed, if you remove one of the oxygen atom here, one of the double bonded oxygen from here, so basically you are going to get S double bond O, double bond O, OH and OH, but due to steric repulsion and all, the actual structure actually exists in this way, that you have sulfur, you have double bond O, OH and OH. Okay, this is the exact structure. This is the correct structure of this. The name for this is your hyposulfurous acid. Okay, so since we know that the oxidation state for your sulfurous is +4, so for hypo it will be little lower than that. So the hypo is going to give you +3 oxidation state for both the sulfur. Okay, So they are going to be in +3 and +3 oxidation state, both of them. So these are like oxoacids of sulfur derived from the sulfurous acid series. Now we have one more series, that is sulfuric acid, and two more of them. So let's quickly see that how to derive or how to find out the structures of them. Alright, so the next series is sulfuric acid series. The first one which we will take is sulfuric acid itself. The formula is H2SO4. We all know that. The structure, how to make it. So see, sulfur double bond OH is necessary. Now the next thing is you are left out with 3 more oxygen. So basically this will be like this, okay. So yeah, 2 of them were used, 2 more were left out. So this is how it will be. So this is the structure of your sulfuric acid. Now let's try and see its derivatives, like with the help of it how we can find out the other oxoacids of the sulfuric acid. So the second one is your thiosulfuric acid, okay. Thiosulfuric acid. Now as I already told you, in the thio means that you have to remove oxygen and you have to insert sulfur. And which oxygen you have to remove? Like it is more favorable if you remove double bonded oxygen. If you don't remove double bonded oxygen, you have to do the resonance and all, right? So the structure will be like this: S double bond S, and it will be OH. Just one oxygen you have to remove, okay, not all the oxygens. So yeah, this will be the formula for your thiosulfuric acid. The oxidation state over here is +6, and here also it should be +6, okay. These are the oxidation states for this. Okay, so the next one is your pyrosulfuric acid, okay. So the third one is your pyrosulfuric acid. So pyrosulfuric acid, as I told you, it's pretty simple. It's not as difficult as pyrosulfurous acid, okay. It's simple. What you have to do, you have to just take 2 moles of this, S double bond O, OH and OH. You have to take 2 moles of it and just remove water molecule, that's all. Okay, so removal of water molecule is going to give you. So the only thing where you have to take care of pyro is pyrosulfurous acid, okay. There the simple reaction does not, or simple removal of water does not makes the structure. So yeah, here you will see that this is what you have. Water can be removed, and the final structure which you will get will be like SOS, and here you have double bond O here also. With this you have single bond OH, double bond O, and single bond OH, okay. So this is your pyrosulfuric acid. The oxidation state over here is again +6 for both of them, okay, +6 and +6 for both of them. The next one from here which you can derive is basically, okay, I'll do here, okay, I'll do it over here. So the fourth one which we can have is your hyposulfuric acid. In this, what you have to do, you have to just remove oxygen from this pyrosulfuric acid, okay. So just remove this oxygen which is binding sulfur and sulfur. So the structure will be what? The structure will be S double bond O, then you have OH, double bond O, single bond S, double bond O, OH, and double bond O. This is what you will get. The oxidation state in this case is going to be yeah, so this particular one is going to have oxidation state of +5, okay. The oxidation state has just decreased by 1 unit because it is hypo. So see, the trend is same, everything is being same, just you have to take care of the name and how you are writing the structure, okay. So this is the sulfuric acid series. 4 oxoacids you can derive from here. Let's go for the next one, that is thionic acid series. Alright, so in the thionic acid series, the first one is your dithionic acid. That dithionic acid is basically the same which we did just now, hyposulfuric acid, okay. So hyposulfuric acid is only called as dithionic acid. So the structure is same, S double bond S, double bond O, OH. You have OH, double bond O, double bond, okay. So the structure is same. This is your dithionic acid. With this we will have some derivatives of it, okay. So remember, the general formula for this is given by the general formula is given as H2 and S. Here the formula is H2S2O6. This is the formula of this, but the thionic acid series has a general formula of H2, and the S is over here as N+2 and O6, okay. This is the formula. Okay, I'll write down here also. So the general formula is H2S N plus 2 and O6. What is N over here? So N can be anything like 0, 1, 2, 3, anything. So for this example, for dithionic acid, N was 0 over here. Okay, N was 0, that's why you are having H2S2O6. So let N is equals to 2. So if I take N is equals to 2, so in that case, what will be my formula? The molecular formula will be H2, and I will have S4 here, right? Because 2 plus 2 will be 4 and O6. This particular molecule is going to have a structure like this. See, you don't have to do with the fragments. The side fragments will remain as it is, S double bond O, double bond O, OH, okay, and S double like OH, double bond O, double bond O. This will remain as it is. You just have to insert sulfur sulfur bonds over here. That's all. So you have inserted it. So you got 1, 2, 3, 4 sulfur, and that's what. So the name of this particular molecule is your tetrathionic acid. Okay, what's its name? It's tetrathionic acid. What is the oxidation state if I ask you? So in this case, if I ask you about this molecule, the oxidation state over here is your +5. Okay, yeah, and here also the oxidation state will be +5 for both of them. Here if you see, it is +5, but for the central sulfur, because these are sulfur sulfur bonds, so their oxidation state will be 0. Okay, so that's how it will be. The next, so this is your thionic acid series. Okay, the next one which we can have is peroxysulfuric acid series. So let's take that also. Alright, so the last series for sulfuric or for the sulfur oxoacid is your peroxysulfuric acid. Now this peroxy basically means that you will have oxygen-oxygen bond in the molecule. Okay, you will have oxygen-oxygen bond in the molecule. So the first one which I am going to take is your peroxysulfuric acid. Okay, peroxysulfuric acid as such. The structure or the molecular formula for this is your H2SO5, and the structure goes like, since you were having sulfuric acid as this, right? You were having sulfuric acid as this. So, but what you have to do in the peroxysulfuric acid, you just have to insert one oxygen. So, if you insert that oxygen, it is going to become like this. Okay, so this is your peroxysulfuric acid. The oxidation state over here is going to be +6. All right. The next one which I can have in this series is your peroxy disulfuric acid. So this is peroxy disulfuric acid. So in that particular case, the formula goes like H2S2O8, and if you try to draw it, basically what you have to do is you just have to take this fragment, this much fragment, make it 2 times. Okay, so this is like S double bond O, double bond O, OH, and S double bond O, double bond O, OH, and you have to just insert 2 oxygen atoms over here. Okay, so this is your peroxy disulfuric acid. Alright, the oxidation states here again is going to be +6 for both of them. How it is coming +6? You know, -2 for these two. This is going to have -1 and this is -1. So -2 is going to give you -4, -5 and -6. So overall sulfur is should have +6 oxidation state. You know how to calculate that. I hope that is pretty simple and pretty basic. So you all know about that. So these were your oxoacids of phosphorus and sulfur, and this was how you can easily find them out with the naming and with relating the name and with how they have been derived from one another. In exam, how questions are asked? The questions are asked based upon how many phosphorus bonds you have in a given phosphoric acid is given to you, and they will ask you how many phosphorus bonds are there or how many phosphorus oxygen bonds are there. So you should be aware about all these things. Okay, so that's what this video was all about. Okay, so I just tried to take all the oxoacids of phosphorus and sulfur. There are few more, like the orthophosphoric acid has its own like dimer and trimer of that. Okay, so I would recommend you to just like check that out. Okay, just see the structures of them. I have not included them, but yeah, I have just tried to give you the basic understanding of how to like find out the structure of a given oxoacid. All right, so that's all for this particular video, guys. Thank you so much for watching. If you like the video, give it a like. If you want, you can subscribe to the channel, and if you have any doubt, you can drop down in the comment section below. I'll try to reply to that particular comment. So that's all from my side. Thank you so much for watching, and have a great day. Bye bye.